Hey everybody, Roy Arsan here. I'd like to introduce you to MedQuery project, which is a biomedical AI research assistant powered by Gemini and BigQuery. What does it do? It allows you to research and understand and synthesize information from the millions of scientific biomedical articles that are available publicly. In fact, for those who might not know, the NIH, the National Institutes of Health, make available through the PMC PubMed Central a full digital archive of more than 11 million articles of biomedical and life sciences journals. Um, they have really powerful keyword and tag-based search. In this case, I'm looking for nutritional journals that are also related to um, public health and potentially some diseases. And um, the the issue here is that this is kind of a keyword text-based search. Um, it's hard to synthesize this information, and if you have a specific question and um, basically get to the bottom of the latest in biomedical research, both as a general population, but also for the biomedical researchers themselves. So um, one area to approach this is to have all these documents indexed and processed in BigQuery. So what you're looking at is a pipeline that is downloading all these articles, with a specific time frame that you're interested in. And then the main approach revolves around multimodal analysis. And yes, we are using BigQuery, big frames everywhere, but uh, you know, um, the key aspect is that instead of analyzing the text, we are embedding the images, for richer information, including charts, image, and tables, but also to capture the semantic relationship of the different content on the page. So what's happening is we are splitting the documents into single page PNG and PDFs. We are embedding the PNG and that we're building our vector index on top of the table of pages. Um, and then you have a RAG application that is built on top. Now, how does that manifest itself? So let's go ahead with a simple, well, not so simple question. So this is a Streamlit application that is talking directly to BigQuery. In this case, obviously this is a non-production environment, but it's running on my local environment. So what's happening here is you have access to the entire, journals that I downloaded. In this case, I downloaded the last 2 years of journals, specifically around nutritional health. There's some metadata here that PubMed provides you, like the journal where this article was published. So let's go ahead and just focus on nutrition, which is one of the journals out there. You can see how this is filtering through the pages. So this is, categorical filtering. The other interesting thing is that you can see study types and population. Now, those were generated using some of the new functionality with big frames, AI functions. In this case, we are using AI classify to classify the study type based on the article text. If we go back to the diagram, this is this bottom part here where we are extracting information, right? We're doing some what normally would be very sophisticated analysis in terms of labeling these articles by study type. We're also doing PICO data extraction. PICO stands for population, intervention, comparable, and outcome. Um, this is a single line function that is doing these analysis. There's a notebook that walks you through the code. But just to show you underlying these rich filters, those are enhanced metadata, data enriched on top of what the PubMed library gives you. And then last but not least, you're selecting how many documents or pages you want to comb through. Um, general rule of thumb is if it's a very narrow topic, you want to choose a few documents. If it's a more broader topic, or even if you're summarizing more than question and answer, you want to select more pages. The more pages, obviously, is the more time consuming it's going to be and costly because you have more tokens. But let's say you're interested in the effects, a very specific question, you're interested in the effect of keto diet for patients with multiple sclerosis. So I'm going to search. This is going to take a few seconds because not only it's performing the vector search, and I can turn on debug mode, which shows me the actual query that is running in the backend. The Streamlit app uses SQL-based query for vector search because it's easier to debug. But the notebook that comes with this to set up the whole data pipeline uses big frames, which is more familiar for those who are familiar with using Panda-like API. So you can see it's already retrieved the result, and I can see the specific pages from different articles, all in the nutrients journal, which is what is expected. Let me turn off the debug mode and give it a few seconds here as the LLM is synthesizing a response. And here we go. The answer has returned. You can see this is a very synthesized answer based on very specific sources. I can actually go ahead and open the specific page of the article so I can dive deep quickly to the source. This is not just the collection of articles, but the specific pages of different articles. The other thing to point out is that, the ability to have the image embeddings and sending the image to the LLM, doesn't lose any context, including, charts like this. So the final answer will include the relationship depicted in this chart depending on the question. So this is very powerful information that is usually lost. So you want to have the answer grounded, obviously, but also have a full context. So you can see some of the summary of the effect of the keto diet. It talks about preliminary studies, and then links to the actual source. And then you can have some more detailed effect of the keto diet for MS patients, and then summarize some key data point based on the articles and pages. So this helps me make decisions based on scientific evidence or find out where the gaps are so I can continue doing some more research. And then, so let's go ahead and tackle another use case. What is the evidence of direct link between unhealthy diets, anxiety disorder, and the increased risk of dementia later in life? Okay. So I'm gonna, leave everything, open-ended in terms of the filters. So this is searching through 15,000 articles. So I've gone ahead and indexed the journals, like I mentioned, around nutritional health from 2024 and 2025. The notebook goes through, helps you go through like the top 100 articles. But, in this case, I have 15,000 plus articles, and then they have been processed and the PDF were split into single page PDF. So we have around almost 207,000 pages. So I'm gonna run this search again. And sure enough, you have an answer that summarizes the most relevant articles and pages that associate, inflammatory diets with dementia and dietary factors with cognitive impairment. So very relevant articles. And then it gives you the specific metadata of each page, which journal it came from. And then you can see how it was able to synthesize all this information over to the left with the link between unhealthy diet and dementia, and then some data points. So let's keep ahead and let's keep going and show you one more use case. For this question, let's retrieve more documents. So what are the most effective exercise routines for reducing biomarkers of metabolic disease? And can you show me data for both men and women? So let's see how this performs. And there we go. So I have synthesized the sources, and the summary is the combination of aerobic and resistance training is consistently highlighted as highly effective for metabolic health and reducing biomarkers, etc., etc. You can see how there's more details about the specific kind of training, and each statement has a citation based on the specific source. And you can see this is a tabular information that was extracted. I can again dig deep into the page and a high resolution page and find out what type of clinical studies were done. So again, to make an informed decision, this has high impact, huge benefit for the general population, but also for researcher, for public health, officials, and then some additional data points. This goes beyond a traditional RAG because it's not only it's analyzing text, image, and data, and charts and tables. It's able to retrieve those, and it's able to synthesize those as well. Well, thanks all for listening. Hope you all can take advantage of MedQuery. Thank you.